Hello, this is Jack Jackson. This video playlist, we're going to be looking more at triangles. It's actually really just a continuation of the previous playlist. And so we're going to be focused a lot on developing triangle congruence properties in multiple geometries. But before we do that, let's just review a little bit about general triangles. Uh, so we can see that here we have a general triangle. We can be defined as taking 3 points, A, B, and C, so that they're not collinear and that they are no two of them is an antipodal pair, which is important if we're going to study spherical geometry, not important if we're just going to stay in Euclidean geometry. And then then the triangle is actually a union of the line segments AB, BC, and CA. Okay, it is not this part in here, which is the interior of the triangle, and it's not the part out here, which is the exterior of the triangle. Now, we have certain things that we have. We have the interior angles here, and for Euclidean geometry, it turns out that they sum up to pi radians or 180 degrees. We also have, so there were 3 of those interior angles, and then we have 6 exterior angles, 2 at each vertex, both of which at each vertex form a vertical angle pair. Now we have some other properties of triangles that are true for all triangles. First of all, they have 3 vertices, which are the endpoints of the sides, and they're also where the 2 sides meet. We have 3 sides, which are line segments, meeting at the vertices, 3 interior angles, 6 exterior angles. They're all points in a single plane, and they have an interior, which is a convex set. And then they have this interesting property here that says this: if we take a line which intersects one side, it's going to have to intersect one of the other sides. So here we have it intersecting one side, here at one side. This one, of course, if it goes through the vertex, it could intersect all 3 sides. In fact, the only way it could intersect all 3 sides is go through the vertices. It could contain a side, but that goes through all 3 sides because it contains points A and C, in this case, which are also on this, C is on side BC, and A is on side AB. So we have, if we have a line there, it has to go through, if it goes through one side, it's got to go through more than one side. Even a line that did something like this, it's still going through just going through one point of the triangle, but that point is on 2 sides. So that's an interesting property that it has. And that's for all triangles, and these same properties are true in all of the geometries we're going to be studying. That is Euclidean, taxicab, hyperbolic, and spherical geometry. That's all true. What's true and only for Euclidean geometry, however, is that the sum of those measures of the interior angles um, sums up to pi radians or 180 degrees. So those are some general properties of triangles, and we'll continue on to look at um, some specific congruence properties here as we go forward in the rest of these videos.